Accuracy and precision. Accuracy refers to how close a measurement is to the true or accepted value. It shows how correct your measurement is when compared to a known standard. If you are measuring the temperature of boiling water and your thermometer reads 100.1 degrees Celsius, your result is accurate because it is very close to the known boiling point of water 100 degrees Celsius at sea level. Precision refers to how consistent your results are when you repeat an experiment or measurement under the same conditions. Precise results may or may not be accurate. If you weigh a bag of sugar 3 times and get 495 grams each time, your results are precise. However, if the true weight is actually 500 grams, your results are not accurate. Accuracy equals how close to the correct value. Precision equals how repeatable or consistent the results are. Reliability. Reliability is about getting the same or very similar results when you repeat an experiment under the same conditions. Imagine 3 groups in a class drop a ball from the same height and measure how high it bounces. If all groups get similar results such as 25, 26, and 25.5 centimeters, the experiment is reliable. To improve reliability, repeat the experiment multiple times and calculate an average. Use a large sample size. Ensure all steps are done the same way each time. Reliable results build confidence that the data reflects what is really happening. Validity. Validity means the experiment measures what it is supposed to measure. A valid experiment is carefully designed so that it tests only one variable at a time while keeping everything else the same controlled. You want to test if fertilizer helps plants grow taller. You plant 2 sets of seeds in the same type of soil, give them the same amount of water and sunlight, but only one group gets fertilizer. If all other conditions are controlled, the test is valid. An experiment is valid if it matches the aim question. It changes only one independent variable. It controls all other variables. The method is suitable for the investigation. Analyzing data to identify trends, patterns, and relationships. When you look at data, it's important to find meaning by looking for trends, general directions the data is moving. Over a week, the average daily temperature rises from 18 to 25 degrees Celsius. That's an upward trend. Patterns, repeating events or values. Every 3rd day there's a rainfall spike. That's a pattern. Relationships, when 2 variables change together. As the amount of exercise increases, heart rate increases. That shows a relationship. Looking for these features helps you explain what the data means and why it matters. Communicating scientific arguments with evidence. In science, you must explain your results clearly and support your ideas with evidence. A good scientific argument includes claim your conclusion or statement about what the data shows. Evidence, data or observations that support your claim. Reasoning, scientific explanation that links the evidence to your claim. Claim, salt affects the boiling point of water. Evidence, water with 10 g of salt boiled at 101.2 degrees Celsius while plain water boiled at 100.0 degrees Celsius. Reasoning, salt ions disrupt water molecules, requiring more energy heat to boil. Also consider how reliable and valid the data is, whether there are any outliers or unexpected results. Using mean, median, and mode to describe data. These are different ways to summarize a group of numbers. Mean, average, add all the values and divide by how many there are. 2 plus 4 plus 6 plus 8 plus 10 divided by 5 is equal to 6. Median, the middle number when data is sorted in order. In the numbers are 3, 5, 7, 9, 11, the median is 7. If there are 2 middle numbers, find their average. Mode, the number that appears most often. For example, in 2, 2, 3, 4, 4, 4, 5, the mode is 4. Use mean when all values are fairly close together. Median when there are outliers, extreme values. Mode when looking for the most frequent value like survey answers. Representing data in various forms. Choosing the right graph helps you understand and show your data better. Scatter plots show the relationship between two variables. Each dot represents one measurement, such as in graphing height versus arm span to see if there's a correlation. Line graphs show how something changes over time. Points are connected to show trends, such as when looking at temperature changes across a week. Column graphs, bar graphs, compare amounts between different categories. Bars do not touch each other. For example, the number of students who prefer different types of fruit. Frequency histograms show how often values fall within certain ranges. Bars touch to show continuous data, such the number of students who scored between 60 to 69, 70 to 79, etc. on a test. Box and whisker plots show the spread of data using 5 numbers: minimum, lower quartile, median, upper quartile, maximum. This helps compare two data sets easily, such as comparing test score ranges in two different classes. Outliers. An outlier is a result that is much higher or lower than the rest of the data. If most students scored between 65% and 85% on a test, but one student got 20%, that's an outlier. Outliers can change the mean, make it lower or higher, make trends harder to see, be due to errors or natural variation. When you see an outlier, ask, was there a mistake in measuring or recording? Does it make sense based on what you know? Should it be excluded or kept in the data? Always explain your decision when dealing with outliers.